In this video, we're going to be talking about troubleshooting motors. Now, motors is one of the most frequently used loads in both air conditioning and refrigeration, actually in the entire HVAC industry. So it's really important you get comfortable with troubleshooting motors. And what I'm going to talk about is a small fraction of it, but we're going to talk about the motors themselves. I'm not in this discussion talking about start components or anything else. I'm talking about the motors themselves. So the first thing you want to make sure is make sure there's voltage to the motors. Okay, there's been a number of times where I've gone out after other technicians who can't figure out why a motor is not running, and I find out that there's no voltage to the motor. So if there's no voltage, you can't expect the motor to run. Check the source. If voltage is present but the motor isn't running, turn the power off and start using an ohm meter. And by the way, when I say voltage is present, I mean voltage is present at the leads going to the motor. Okay, not at the leads coming into the unit. You need to find the leads going to the motor and make sure that voltage is present. Thoroughly check all motor components, okay? Do check out the start relays, do check the capacitors. Ohm out the motor windings. You want to check for open windings. You should have a measurable resistance between S, C, R, and C, and S, and R. In other words, check start to common, then start to run, then run to common, then run to start. Make sure you have measurable resistance. Write these resistances down. The resistance you measure between C and R and C and S should add up and be close to the resistance you measure between S and R. Okay, in other words, they should have a mathematical relationship. If the motor's hot, there could be an internal overload that is most likely open if you don't get good resistances or if you get an OL. Wait for that motor to cool. Shorted windings, your ohm readings, okay, your ohm readings on shorted windings will not add up properly, okay? So you want to add up the readings between S and C and R and C, and they add up the reading between S and R. If they don't, you probably have a shorted winding. Three-phase motors should have identical ohm readings on all windings. To check for grounded windings, you should have infinite resistance between any of the windings and the shell of the motor. Okay, so take your ohm meter and check between S and ground, R and ground, and common and ground. You shouldn't get anything. Okay, if a breaker's tripping, a lot of times most likely the motor is grounded. Not always, but it's a good hint that you have a grounded motor in there someplace. If the motor checks out electronically but still won't start, it has a mechanical failure. There's not much you can do. Replace the motor. Okay, and a lot of times you can feel this. If you try to turn the motor shaft, if you try to wiggle it back and forth, you can actually feel if the bearings are starting to go out. So resistance readings here, C to R, you have 2 ohms, C to S, 8 ohms, R to S would be 10 ohms. You're fine. Okay, so again, you'd have a good motor if everything is closed. If you have an open winding, a break in a winding, that's the one we're talking about over here, you would get 0 O or OL between R and C and R and S. You get good reading between C and S. That's why it's so important to check all directions. Okay? If it's a shorted winding, you'll get some weird readings between C and S and R and C. Okay, you'll get really strange readings and it's not going to add up properly. If it's grounded, it means that one of these motor windings has actually connected with ground electrically. So you might have S to C as a good reading. You might have R to C as a good reading, but when you start taking any one of these components to ground, to the shell, if you like R to the shell, you'll get resistance, which you shouldn't get, should be infinite. This is just a look at the internal parts of a motor, you'll see that there's a thermal protection overload right there. It's internal. You can't do much about it if it goes bad. Your start windings are the smaller wires. Okay, run windings are usually the larger wires. But there isn't much you can do about it if that internal overload just fails in the open position. This is just another picture of the same thing. You have your start winding, you have your run winding, and you have an internal overload here. Again, if this fails, there's no way to change it out. You're just going to replace the motor. If any of these windings break and touch the outside housing, you're going to change it out. If any of these windings are broken internally or shorted together, you're going to change it out. There's nothing you can do to fix these motors. So again, motor troubleshooting is important. There's basically one tool. It's your ohm meter. Okay, and then with the motors running, you also want to watch your amperage, because you can get high amperage on a motor where the bearings are failing. So there's two different things you want to do: amperage and ohms. Ohms you always do with the power shut off and the motor isolated. Amperage, power on, comparing your running amps under load to the amperage that's stamped on the unit or the motor. And just as a side note, if you're checking a condenser fan motor or a blower motor, try to always look for the label on the motor to find out what your amperage should be, because a lot of times people are using what we consider rescue motors these days. It's not original equipment, and the amperage may be different than what's on the plate of the unit that's on the data plate.